5, they want us to actually solve for y. So they give you a derivative, right? They give you the derivative of a function, and they also specify the value of that function at a certain point. And what they want us to do is solve for y with the specific solution for the constant of integration, right? So we have to use that initial condition so that we could also get the c, or that's how we're going to solve for that value of c. So anyway, let's go ahead and get started so you guys can see what I'm talking about. So first thing, we want to express the f prime of x as dy dx. Okay. And then we want to make sure that we put our dx on the other side so that we just have kind of like the derivative of y with respect to x, but we're just going to have the derivative of y by itself. And now we have 2x minus 1 dx, right? And what we could do now is we could integrate both sides, right? We're going to integrate both sides, and we already know that the integral of dy, because it undoes the derivative, right, is just going to be y. And we're left with y is equal to the integral of 2x minus 1 with respect to x. And now we could go ahead and actually solve that. Well, when we take the derivative of the integral of 2x, we're going to be left with 2 over x squared, right, divided by 2. And then the integral of negative 1 should just be minus x. We could simplify that out. And we're going to be left with y is equal to x squared minus x plus c. And then now we use this fact, right? They tell us, well, f of 2 is equal to 5. So when we plug in 2, we're going to be left with 5. And just to simplify this, okay, 4 minus 2 plus c. This becomes 2, and we see that we're going to get c is equal to, right, this becomes 2, and then we subtract it out. We get c is equal to 3. So we figured out our function. Our function is going to be x squared minus x plus 3, and this function meets those conditions. And the main point is you have to you're given this to find that c value where that's true, okay? And you could always check your answer, right? If I take the derivative of this, would that give me that, and so forth. Okay, let's look at another example. Okay, this one's a trig function. So we set up the same thing. Let's express f prime of x as the derivative of y with respect to x. And when I do this, the first thing I want to do is I want to get the derivative of y by itself, and we're going to multiply dx to both sides. So dy is equal to 2 cosine x dx. And now we're going to integrate. And when I integrate, I'm left with y is equal to the integral of 2 cosine x dx. And we go ahead and take the integral of that, and we know that the derivative of sine gives us cosine, so going backwards again, or you could look at your rules for integration. We're going to be left with 2 sine x plus c. Okay, we're going to be left with a plus c. And again, they give us, they tell us that f of pi over 2 is equal to negative 3. And remember, y is the same thing as f. So when we plug in sine of pi over 2, we end up getting negative 3. And again, what is sine of pi over 2? It's just 1. So this becomes negative 3 is equal to 2 times 1 plus c. And now I solve for c, subtract both sides. C is equal to negative 5. So my function, my y, or f of x, is going to be equal to 2 sine x minus 5. And this function meets both of those conditions. Okay, let's look at other examples here. If we look at C, I'm actually going to let you guys try this out, practice it out. It's the same idea, just, explain f prime of x, or set up x prime of x as dy dx. Take the x of both sides, and then take the integral and see what you guys get. But if you want to try it, maybe pause the video since I'm going to be providing the answers. Your f function for this problem is actually, there's no denominator here. Okay, again, I'm not going to be solving these out. It's just the same idea. Maybe pause the video, try it out by yourself. Same here. Solve for GT. Again, the easiest way, express the square root of t as t to the 1/2. That might make it easier for yourself. And your answer should be and again, don't forget that we use this to get that value of c, right? Where this actually tells us, hey, we have the general rule for all of the family functions that meet this, but the g9 is equal to 6 gives us that specific function translated 12 units down in this case. And then the final one, again, pause the video, try it out, and this is the function you should get.